Okay, so this topology I borrowed from another project that I was working on previously, but I thought it would work perfectly since we have our two firewall enabled routers right here, and we can set these up for interchassis redundancy very easily. I already have firewall enabled router 1 configured for NAT and firewall functions, and for this scenario, let's just pretend that we just added firewall 2 and we have it configured right up to the point where we would need to implement some sort of failover mechanism to get it to work correctly. So I have the LAN interface configured. I have the firewall security zones configured and NAT configured. There's no IP address on the WAN interface right here for now because in order to get things to work through firewall number 1, I just have what is going to be the virtual IP assigned as the IP address here and a default route from core number 1 going up to this guy right here, so 192.168.255.3. So this is all going to change when we configure interchassis redundancy. This LAN side is going to have a virtual IP, and the WAN side will have a virtual IP, so these can both work as a group in case there's a failure over here or a link failure. It will fail over to firewall 2. So this right here is something that I haven't, like I said, this was from a pre-existing project that I was working on. So I hadn't got to the point where I configured any of these access switches or anything. So we're just going to test this out using Core 1. So just ignore this stuff down here. So to start, let's just make sure we have basic reachability to the internet. Let's see. Actually, we're not going to have basic reachability to the internet via domain name because I haven't configured a name server. So let me go ahead and do that right now. Okay, so we have basic connectivity from Core 1 through Firewall 1 up through here to the ISP. And so now the situation is we want to add another firewall or a router-enabled firewall, which is doing NAT and firewall functions. So what we've done here is we've added a switch. We've requested a /29 transport link from the ISP, so that way we can break this out between these two firewall-enabled routers. So we'll have .250 over here, .251 over here, .252 will be the virtual IP. And on the LAN side, .3, .4, and then .1 will be the virtual IP. So up here on the WAN side, 192.168.2.248/29 subnet, and then on the LAN side, 192.168.255.0/29 subnet. And the pool of IP addresses that we've been assigned from our ISP is 192.168.3.0/29. So that is what these private RFC 1918 addresses will be natted going out to an address in the NAT pool in this range right here. And yes, I know these are also private addresses. This is obviously just a lab, so there's no need for me to use publicly routable IP addresses here. All right, so the first step in getting this configured is configuring the interchassis redundancy link for the data in the control. So that's what this link right here is going to be for on Gigabit Ethernet 0/7. Now you do need to have an IP address assigned on each interface. So this will be a layer 3 interface going across here. And as you can see, I've already done that. So this is 172.16.20.1. And then over here is 172.16.20.2. So the first step in getting these configured in a high availability group would be to enable the interchassis redundancy feature. And we can do that by going redundancy, application redundancy, choose a group. We'll go with group 1. We're going to choose RG1 for the name. This will be the primary, so we'll set the priority to 105. We're going to enable preemption. And let's set the data and control interface, which is, like I said, gigabit 0/7. So data, GI 0/7, control, and protocol 1. And I'm going to go back and forth between the two to keep this even. So on firewall 2, same thing we just did on firewall 1, redundancy, application redundancy, group 1, name RG1. We're going to enable preemption, but we're going to leave the priority as the default, since this will be the standby. Set our data interface, control interface, okay, and that is the first step. Now these two should enter a negotiation stage where they work out who is active, who is standby, and we can look at that by issuing the show redundancy application group 1 command. So this one's still initializing. I assume the same for the other side. Give them just a second, and there we go. So now they have negotiated their roles. As you can see, this one is active. Peer role is standby. And we can view the same thing over here again. Okay, so that's step 1. So now remember what I said. We had this configured just for the single firewall-enabled router over here to begin with. So the transport link that the ISP is routing this pool of addresses to is routed down to 192.168.2.252 as its next hop, which is actually assigned to the interface on firewall 1. Whoops. So we can see that IP address there. So in order to have these both work together in a group, we want this to be the virtual IP, and we're going to assign these IP addresses on each WAN interface on each firewall-enabled router. So we'll do .250 over here, .251 here, and configure the virtual IP for .252. Okay, so we've assigned the IP address 192.168.2.250 to this interface, and now let's configure it for its virtual IP using the interchassis redundancy method. So this is similar to HSRP or VRRP or GLBP, except the command is going to be slightly different. We need to define the redundancy interface identifier and the group, which is where we define the IP address, that virtual IP, and it also does not peer with the other node by sending hellos like HSRP does. So this is all done over the this peer link right here. So if this was, say, this was HSR, these were HSRP. These interfaces were both part of an HSRP group. They would exchange hello messages back and forth. And interchassis redundancy doesn't work like that. Everything is communicated over this link right here. So with that being said, let's configure the redundancy interface identifier. I'm just going to give it a number of 100. Set the group, the virtual IP. We have to put exclusive, and then we're going to do decrement 100, which is going to say if anything happens to this link, if the line protocol goes down, we want to decrement the whole group 100, which will then effectively make firewall 1's priority for the whole group lower than firewall number 2. Firewall number 2 will become active. And then we want to do the same thing over on firewall number 2. And this is going to have an interface IP address of 192.168.2.251, and the same thing with the virtual IP. So we're going to have the same redundancy interface identifier and the same group and the same IP for the virtual IP. So we'll go interface gigabit 0/0, IP address 192.168.2.251 with the /29. Okay, now we have both sides set up in the with the same redundancy interface identifier, which is 100, both in the same group and both sharing the same virtual IP. So if this goes down or this link goes down, this takes over as active. Now the next step is going to be configuring the LAN interface. And just like the WAN side, right here we have this switch pointed to the IP address that is on this LAN side. So the default gateway, actually, let me just go ahead and bring it up. Is 192.168.255.3. And just like I said, just like we did on the LAN or the WAN side, once we convert this over to use the interchassis redundancy mechanism for that virtual IP, then we're going to change this default route to go to 192.168.255.1 as its next hop. So let's bring these firewalls back up and go to the LAN side. And now just to show you, I've already configured these just like on the WAN side for the with the NAT commands and the firewall security zones. So and these already have IP addresses in there, the proper IP addresses assigned to their interface. So on firewall 2, so we have 192.168.255.3 and then .4. So all we have to do now is just give it the interface identifier. So we'll go 200 for this. And redundancy group 1, 192.168.255.1 exclusive. And then again on the primary, we want to decrement that if this goes down, so that way we can fail the whole group over. Okay. And same thing over here on firewall number 2. Redundancy RII 200. Redundancy group 1 IP 192.168.255.1. Okay, so now these we'll be sharing this virtual IP address right here, and this will be primary. So if we go back over to core 1, we see that virtual MAC for interchassis redundancy on ports or on port gigabit Ethernet 3/3, and that would be this one right here. If I do the if I show the interfaces here, Gigabit Ethernet 3/3. Okay, so now all we have to do is switch over that default route, because remember, we have this pointed to the interface IP address, so if this fails, we definitely want firewall number 2 to take over. So let's get that out of there and put in the new default route. All right, and we should have reachability to the internet at this point, and we do. And just for fun, let's go ahead and test a failure really quick, just to make sure that firewall 2 will take over, and then we will configure this for NAT and firewall to sync the states of both. So let's just go into Gigabit Ethernet 0/0 and do a shutdown just to simulate a failure. Let's bring up firewall 2 so you can see what's happening. And you can see that the role changed from standby to active. Let's do another ping out to the internet, and we have reachability. So the failover was a success. All right, so let's bring this back up. And let's move on to making NAT highly available. So if we look at our existing NAT configuration, you can see that we have the typical NAT statement in here, IP NAT inside source list, and then our access list defining which addresses are allowed to be NATed, and the NAT pool, which would be this group of addresses right here, and then overload. Let's get rid of that. And we want to type pretty much the same thing, except we want to assign it to the redundancy group and give it a mapping ID, so that way it will sync the NAT translations between these two. So let's go IP NAT inside source list NAT ISP1 pool ISP1 redundancy group 1 mapping ID. You can put whatever you want. I'm just going to give it a mapping ID of 100 since that's the redundancy interface identifier on our WAN interface, so why not? And then overload. And then the same exact thing over here on firewall number 2. Firewall number 2 has a similar NAT configuration, so we want to take that out. Use the same redundancy group and the same mapping ID. And overload. Okay, and that is all you have to do now to get the NAT translation synced up. So now let's do a... Shouldn't be anything in there since I just cleared out that NAT configuration. So now let's do a ping to Google once again. Look at the NAT translation and in firewall 2, and there you go. You can see that they have synchronized between the two firewall enabled routers. All right, so the last step is to get the firewall states synchronized. That is enabled by this simple command. So you go parameter map, type inspect, global, and then redundancy. Same thing over here. Parameter map, type inspect, global, redundancy. Okay. So we'll get this ready to go so we can make sure that the firewall sessions are synchronizing. And this is a leftover session from previously. Looks like a Telnet. So let's do another. Let's do another ping to Google. Oh, what am I doing? This is the wrong. I'm gonna go to core 1. Ping, and let's look at that. Actually, let's do a let's do Telnet. So we actually have a TCP session that stays established. I think that would work better. So let me Telnet from here into a device on my actual network. I think that would be a better test. So here we have my core switch and my actual production network. And let's do the show policy map, type inspect zone pair, LAN to WAN sessions. All right, so we see the we see a connection has been initiated from 192.168.255.5 with the source port of 31.560 going to 10.0.50.4, port 23 for Telnet. We see that the high availability state is active, redundancy group ID 1. And now if we go over to firewall number 2 and we look at the sessions, we see that we have the same exact thing over here. High availability state, standby, redundancy group ID 1, and here's that same exact connection. 192.168.255.5, source port 31.560 to 10.0.50.4 on port 23. So we're now syncing the NAT translations as well as the firewall states. And just for fun, while we're connected to this switch right here via Telnet, let's simulate a failover and see how fast this works. So we'll shut down the WAN interface. Boom, we're already active on firewall number 2. And we haven't even skipped a beat as far as our Telnet session is concerned, because the NAT translation was already there, the firewall state was already there, and that instant move from that transitioning from a standby to active state on firewall 2 was so quick that we didn't drop any sort of connection or anything like that. All right, now the last thing is just one more thing. Excuse me really quick while I take a drink of water. This is something worth mentioning so you don't end up with a unicast flooding situation. Like I mentioned previously, the virtual IP configuration doesn't work quite like HSRP or GLBP, where you're sending these keep alives, these hellos through here, which contains the, so if this was HSRP on both the WAN and the LAN, sides, the active virtual gateway would have the virtual MAC as its source MAC address in the hello message, which would keep the MAC address table of the switch updated, which would also keep the MAC address table of these switches updated as well. Since interchassis redundancy doesn't work like that, and everything is synced through this data and control link right here, the MAC address table will, the aging timer will cause that MAC address to disappear out of the MAC address table, I think after 5 minutes or so. And this may not be correct, but I want to say that at least on Cisco devices, the ARP cache will be held for 4 hours, roughly. So that MAC address will not go back into the MAC address table until that ARP cache times out and the default gateway, that virtual IP, is ARPed for again. In which case the MAC address will only last in the MAC address table for 5 more minutes. And what happens when a switch receives a frame with an unknown MAC address for its destination? Well, it floods it out of every single port except the one that it was received on. So once that MAC address is forgotten here and forgotten here, what's going to happen is that traffic coming in from ISP1 is going to flood the frame to both Firewall 1 and Firewall 2. Of course, Firewall 1 is going to be the only one that's going to accept it because it will be active. But still, you don't want that kind of behavior occurring. And the same thing with the LAN side. Anything going up here is going to be flooded to Firewall 1. It's going to be flooded to Core 2, and then out to Firewall 2 as well. So, and the same thing with any traffic that might be going to Core 2. Now, I know we're using the cores as the example, as the end devices, since I didn't have anything else configured, but if this was a production network where you have these access switches up and your device is connected off, anything going up here to Core 1 or Core 2 is going to be flooded out of all these ports once that MAC address is forgotten. So what we want to do is we want to change the aging on the MAC address table. And let me just see if it's probably still in there. It is. Okay. I was kind of hoping that it would have forgot it, so that way it would make a better example, but no big deal. So what we want to do is, we're on VLAN 2. So this link and then these links, they're all on VLAN 2. So we want to issue the MAC address table aging. Now we could disable it completely, or we could set an aging time in seconds. So let me see. Let me take a look at this really quick over here. This is off the screen. I just want to remember what it was that I set it to in seconds to match what the ARP cache aging would be. So that would be 14,400. So what you want to do is adjust the MAC address table aging time. You can either, like I said, you can disable it or set it to something like 14,400 seconds, which should equal 5 minutes. So, I'm sorry, which should equal 4 hours. So the ARP cache, in the MAC address table aging will match up. So on the WAN switch we have here to connect ISP1 to both of these, we're going to adjust that right there. And we want to do the same thing on the cores. And we are on VLAN, I think VLAN 255. Transit to firewall. Yep. So this is just this is a layer 2 segment right here between these two cores and the firewalls, all on VLAN 255. So we'll go MAC address table aging. Actually, hold on. Let me go back to ISP1. I mean, WAN switch. I'm sorry. I think I just did that globally. That's not so. MAC address table aging time, and then the time in seconds, and then the VLAN. So, like I said, VLAN 2. So make sure you don't forget that. So again, on a oh wow. I forgot I'm still telnetted into my my actual switch. Ooh, okay. That was close. Wow, I didn't notice that. So remember how we were using Telnet as an example to see if those firewall states were synchronized, and I totally went into this not realizing that I still had a Telnet session established with my actual core switch in my network, and here I was going to change the. And it's funny because it is actually VLAN 255. I mimicked what I had set up in my own network. So this is VLAN 255, and it's also VLAN 255 in my network as well, because I have mine set up very similar to this right here. So, but let's get out of here and let's go back to the actual core. So we do a show VLAN brief. This layer 2 segment is on VLAN 255 to firewall, just like I suspected. So, oh, that was close. Okay, so yes, MAC address table, aging time, 14,400, VLAN 255, and the same thing over here on core 2. I think you get the picture at this point. So I don't think I actually have to follow through, but why not? All right, and that's all. That is every step that you need to perform to configure interchassis redundancy on Cisco routers doing NAT or a zone-based firewall, or both, as shown in this scenario. Just as a side note, for this feature to be compatible, you do need to have at least a Cisco ISR Generation 2 router with a security license, that is, if you want to do zone-based firewall. If you have any questions, you can reach me at via email at rob@rmtechcentral.com. If you like this video, please hit the thumbs up button, and if you'd like to subscribe, please do. I would really appreciate it. Anyways, thanks for watching. I hope you learned something, and I will see you in the next video.